Hi everyone, we're going to do some examples on molar concentration for you now. So you will have gone into content and you would have accessed lesson 7 right here. There would be a what do I do that will bring you to the summary note on molar concentration. It's right here. And you're going to run through the main resource note and you're going to fill in these questions. So if we just head into the main resource note, we have to go back to lesson 6. Again, I don't have the ability to copy the main resource note and put it in the content every time. And you're going to scroll down to where we see lesson 7 starting. So we'll wait for my Chromebook to unfreeze. There we go. I don't know why that's up. Here we go. Here's molar concentration here. So let's just go back a bit. There it is there. Lesson 7 begins here. So yesterday we did some work on percent concentration. And the reason that we use percent concentration is those are concentration values used in retail or in stores where you would buy solutions of chemicals. Molar concentration is used in the chemical industry. Okay, so if you worked in a lab or you worked in a factory and you were dealing with solutions of chemicals and you needed to know the concentration, so how much solute is dissolved in the solution, we tend to represent that in the chemical industry by the mole value. Okay, so it's been a few days since we've looked at moles, but they don't go away. Those are what we use in the chemistry industry. Now, if you go and you buy a sample of bleach or vinegar at the hardware store or in the grocery store, the average person doesn't know about moles. So this is why we don't use molar concentration in a retail setting. That's why we use percent concentration. But molar concentration is very, very common in lab settings. And we're going to get you to read through here. There's a really good simulation right here, okay, that you can click start. And when you're using that simulation, you just got to scroll down here where it says press the following tabs to access the simulation instructions. Okay, so go through that and definitely give that a try to give you a sense of us making solutions now using mole values. So here are our concentration, our molar concentration formulas. Okay, so we're going to use a new formula today where we're still taking solute over solution. That's what we are always dividing those two out. But we're going to use some different symbols, and the units are now going to change when we deal with molar concentration. And because we're dealing with molar concentration, we have to revisit that formula for moles. And then I'm going to take you through, there's 4 examples here. I'm going to take you through these 4 examples. So let's head on over to our Jamboard here and let's talk about these formulas for calculating molar concentration. So molar concentration is going to be denoted with a little c, and we're going to take moles divided by volume in liters. So I always put a capital L after my volume, just to remind me that I need my volume to be in liters. So when we were dealing with percent concentration, our volume had to be in milliliters, and it's different now. Okay, so make a note for yourself that you have to have these units in liters. So C is going to be molar concentration, and our unit for molar concentration is moles per liter. V is our volume. It's going to be measured in liters, and little n, again, been a while since we've seen it. This is our value of moles, and the unit for moles is mole. If you're a triangle person, this is how we set up the triangle. We put little c in the bottom corner, moles up top, volume in liters on the other side. And remember, anything above and below this line, we divide. Anything on either side of that vertical line, we multiply. Okay, so that's a division and then a multiplication if they're side by side. We also have to recall this formula. So moles is equaling mass over molar mass. because now that we need to solve for moles, lots of times we start with a mass value and we have to convert. So this is another formula. We saw this last week where we can use those variables as well. Okay, and remember, little n is moles, little m is mass in grams, has to be in grams. And remember that this fancy m is molar mass off the periodic table, and that unit is in grams per mole. Okay, so the nice thing for you at home is that you can write all these down and have them handy and refer to them as you need. So let's start to go through and let's do a calculation. It says potassium chloride is a common salt solution used in the production of fertilizer. Calculate the molar concentration. Okay, so this is what we're solving for. So molar concentration is C. I don't know what that is. Of a solution that contains 0.186 moles. Oops, so that's my mole value, my little n. So 0.186 moles dissolved in 250 mils of solution. So remember that my volume has to be in liters now. So if I'm taking 250 mils, I have to divide that by 1,000 mils per liter, and I get a value of 0.250 liters. Okay, really, really important now that your units are properly represented. Okay, because again, you got to be careful. Sometimes it's milliliters, sometimes it's liters. Molar concentration, we need liters. So we want to solve for the molar concentration of potassium chloride. We're going to set up our formula, moles divided by volume in liters. We already converted. And we put in 0.186 moles divided by 0.250 liters. And everybody should have their calculator out and handy, okay? And you should be punching this in with me to make sure you're getting the right answer. And my calculator is saying 0.744. And the unit is this, right? It's moles per liter, because that's what we did. We took moles and we divided out by liters. And typically we round to 2 decimal places, so we're just going to round to 0.74 moles per liter. Let's try another. Household bleach is an aqueous solution made by dissolving 5.25 grams of sodium hypochlorite. Okay, so right there, let's jot down what we know. We know that the mass is 5.25 grams. Okay. And they're talking about the active ingredient in bleach, which is sodium hypochlorite. And then it says per 100 mil of solution. Calculate the molar concentration. Okay, so little c is what we're solving for. They gave us the volume, and remember that for molar concentration, we're going to need that in liters. So what we're going to do is we're going to take 100 mils, and I assume you can convert to liters. You're going to divide by 1,000 milliliters per liter, and we're going to get a value of 0.100 liters. Now, the other thing that we have to do is they gave us a mass, and so we have to calculate moles here, right? Molar concentration is moles divided by my volume in liters. Well, I don't know what moles is, but I can calculate it because they gave me a mass value. So we need 2 steps here. We're going to number our steps, and we have to figure out the moles of sodium hypochlorite by taking mass divided by the molar mass. So we're going to do 5.25 grams, and then we need to stop, and we have to figure out the molar mass of sodium hypochlorite. So again, practice with me here with sodium hypochlorite. I have 1 atom of everything, and the mass of a sodium is 22.99. I only have 1 of them. I'm going to add on 1 atom of oxygen, which is 16. And then this is Cl. Okay, sometimes students think that it's carbon and iodine together, but it's not. It's chlorine. So we add on the mass of 1 chlorine, which is 35.45. and I am getting a molar mass of 74.44 grams per mole. I'm going to divide those out. You're going to follow along and hopefully you're getting the right answer. And I'm getting a mole value of 0.07053. I'll stop there. Moles. Okay. And then I'm not done. I got to figure out molar concentration. So to solve for molar concentration, and we'll just write out here what we're solving for, we need to take moles divided by my volume in liters. So we just calculated our moles, 0.07053, and then we divide by our volume in liters, which we've already converted, so 0.1 liters. And then we just divide our mole value by 0.1, and I end up with a mole value of 0.71, or sorry, molar concentration value of 0.71 moles per liter. Okay. So again, sometimes they're going to ask us to solve for moles, which is not an issue. You know how to do that. And again, we just revisit this old formula that we learned a while back. Here's another question. It says the concentration of magnesium chloride in seawater is 0.055 moles per liter. Okay, so this value that they just gave us, that's the molar concentration. Let's write that down. So C is equal to 0.055 moles per liter. Okay, so we know that. It says what volume of seawater is required for 5.2 moles of magnesium to be dissolved in the water. So my mole value is 5.2 moles. My volume in liters is what I don't know. Okay, so we're going to solve for that. So we have our formula, so C equals N divided by VL. And I have to solve for something in the denominator. I do not like it there at all. Okay, we have to get it out of the denominator. Our unknown always has to be in the numerator. So there's a quick little trick you can do. You just would take C and V and you would flip spots with each other. Okay, so for example, you just change their position. And so volume would equal moles divided by C. Alternatively, if you're not interested in that, use your triangle. Okay, so C N V L. If I'm solving for VL, look what I'm doing. I'm taking moles and I'm dividing it by, right, because that's what this line means, dividing it by the concentration. And that's what we're doing right here. So we're just going to sub in our values. Moles go on top, 5.2 mole divided by 0.055 moles per liter. And we divide this out. Do this with me. 0.055. And I'm getting an answer of 94. And we'll still go to 2 decimal places. 0.55 liters. Okay, is my answer. All right. Last example that we'll do together. What mass of sodium chloride is required to make a 500 ml solution that has a concentration of 0.25 moles per liter? Okay, so again, we're using molar concentration, but we also need our mole values here as well. And this question is asking for mass. So we need lowercase m to be solved for. We are trying to make a solution that is 500 milliliters. So we need a volume in liters. So what we do is we take this and we divide by 1,000. And when I do that, I get 0.500 liters. My molar concentration is equal to 0.25 moles per liter. And in order to solve for mass, I'm going to have to recall my 2 formulas. So here's the one. Here's molar concentration is equal to moles divided by volume in liters. And then we know moles is equal to mass divided by molar mass. So which formula do I start with? I have to start with this one because I know molar concentration. They told me that. and I also know my volume in liters. So then I can solve for moles and then use this second formula to solve for mass. So let's set this up. I'll start over here. So step number 1, I have to figure out the moles of sodium chloride. And what I'm going to do is I'm going to cross multiply C times VL. And then I'm going to be able to solve for my moles. So again, you can use a triangle to help you with this as well. Okay, so if you're a triangle person, there it is, C, N, V, L. And again, we're going to multiply those if they're side by side in the triangle. So we take 0.25 moles per liter, and we multiply by 0.5 liters. And I get an answer of 0.25 times 0.5 equals 0.125 moles. And then I need to do a second step. So I now have to use this formula, and I'm going to cross multiply moles times molar mass. And I'm just going to clean this up a little because I'm getting messy. Okay, and I need more room. Okay, so step 2 is going to be me solving for the mass of sodium chloride by taking moles times the molar mass of it. So we know the moles, it's 0.125 mole. And then what's your molar mass of sodium chloride? Well, sodium is 22.99 and a chlorine weighs 35.45. There's only one atom of each. We get a total of 58.44 grams per mole. We multiply that with 0.125, and I am getting a mass value of 7.31 grams. Okay, and that's how much sodium chloride I would have to weigh out. And then I would take that and I would dissolve that in 500 mils of water, basically. And then I would know the concentration of my solution. So here were 4 different ways that we could use molar concentration, the calculation, and solve for different things. But each time, I think almost each time, we had to bring in the 2 formulas. So we needed to know or be aware of the mass over molar mass. And then we had our concentration equaling moles over volume in liters. So important that we understand each of those formulas.